Okay, so today we're going to start chapter 3, section 1. Going to deal with a couple, this should be a quicker lecture. We're going to talk about some random things here just to get the ball rolling here. So some of the stuff's going to build on what we've had before. Some of it's going to be brand new to some of you, and we'll hopefully be clear afterwards here. So we've talked a little bit about this E. If you might recall from before, it's a constant number that's always equal to 2.7. Kind of like pi is always equal to 3.14. It's always representing that number. We're kind of all familiar with that. E is always going to be this, what they call the natural number. It's always about 2.7, and it goes on further and further. That's just the approximation that is used. And they call it that the natural number just because it does literally occur in nature in a lot of instances. We're going to see things like population growth of humans, of animals. We're going to see plant growth. We're going to see radioactive decay, all kinds of things like that. It's one of these very unique numbers that seems to work. Like I said, just like how pi is always involved in the area and the circumference of a circle, anything circular, pi is involved. Anything that has to do with any growth or decay, this E, this natural number, is always used. Okay, so how does that apply to what we're doing? So we're going to get some word problems that I'll admit are not necessarily business style, but we're going to make this, there are some applications that happen like this. So this right here is interesting. This is what happens as n gets bigger and bigger and bigger of this expression. So as n gets bigger, remember what's happening here. This little fraction is getting, it's a big denominator. So this fraction, it gets tinier and tinier. This parenthesis gets closer to 1. But the power is getting bigger and bigger and bigger. So you get something that's approaching 1. You get a power that's getting bigger and bigger. What does that number approach? Well, it approaches that natural number, this E right here. Okay, so the official definition is the limit as n approaches infinity of this. They have another definition, which is just another rewrite. It's another form of this. And they both mean the same thing, but like I said, what matters is this part right here. It's 2.7, all this, and like pi, it goes on forever. It has no discernible pattern. It just keeps going. Okay, so we're going to talk about compound interest, and that's what matters here in this case, where we're talking about a principal, and just so we're clear, when you talk about interest, whether it's a bank account or a credit card, anything where money is earning on top of itself, capital P is always the principal, which means that's the starting amount, what you begin with, or any point that you start the problem. Your annual percentage rate is the R. I'm going to talk about that in a second. T is the time in years. M, the number of compounding periods of a year. Now, what I mean by that is if they tell you that you're getting interest, say, monthly, then your M would be 12 because it's happening 12 times in a year. If you're getting interest quarterly, like some accounts do, then M is going to be 4 because you get 4 times that they're calculating interest. Other things like certain credit cards or certain banks you might hear, they calculate interest daily. Then your M would be 365 and so forth. But that M is how many times in a single year. And then capital A is going to be what's the final amount. Now they call it the amount. Realize it's essentially after T, after a certain number of years, your principal is going to become a final amount. That A is what your final amount is. Now the last part, I'm going to go back here talking about this R, this annual percentage rate. So if somebody tells you, or if you get a problem, and they say, okay, like at a bank, the APR, the annual percentage rate is, say, 3.7%. That's not what R is equal to. Okay, it comes from the annual percentage rate, but R is the decimal of this. Meaning, don't give me a percent. We want to convert this. In this particular case, it's the 0.037. Basically, take your percent, divide it by 100, and you get what that little r is. Okay, and the reason we do that is because that's what we're going to use when we plug numbers into our calculator. We don't put percents in. We need to put in actual decimals, like in this case, instead of 3.7, we're saying 0.037. That's going to be the value that we use whenever we plug things in here. And we're going to get a couple of formulas, mainly one that we're going to use the most. So a couple of these. Let me just put them all up on the screen here. We have simple interest, compound interest, and continuous compounding. Now, I'll briefly talk about these. Simple interest, it doesn't really come up much, but sometimes it's used. It's a case where, let's say I take out a loan for $1,000 and I'm doing a simple interest account. What happens is when I pay interest, it's always based on what that initial loan was, your $1,000. Okay, that's what simple interest is. So it's the same interest every single time, whether it's monthly or quarterly or yearly or daily. It's the same interest every single time. The balance does not affect the interest. It's all based on the initial starting amount. Compound interest is what we mostly deal with. If you ever look at your credit card bills or your bank statements, you'll see what's compound interest and how this works. We'll get to this big formula in a second, but basically, if I have $1,000 and I'm earning, say, 1% interest, at the end, when I get paid that first interest, I'm going to get paid $10. It gets added to my account. And the next time they do interest, it's based on my balance, which is now $1,010. So I'm going to get $10.10 or something. And I'm going to get a little bit more interest because that's what you hear, the interest of your interest on top of interest. That's what compound interest is. And credit cards do that when they charge you interest the other way. It's not based on how much that charge was. If you went to Best Buy and buy a TV for $500 on your credit card, you're not, your first interest is going to be based on that $500. Then as soon as they add that to your current balance, now your balance may be $520, and the next time they run interest, it's going to be on the $520. So that's a case of interest on top of interest going the other way, going against you. Now, the last one is where this E comes in, this continuous compounding. So, like I was saying, you can have interest every single day, every month, every quarter, every year. And the way the formulas will work out is, well, the more often you compound it, the less the interest is going to be, as in the percent rate. You kind of, when you get an APR, like I did that 3.7 earlier, if I compound interest one time a year, I take 3.7. If I'm doing it 2 times a year, I don't do 3.7 in June and then 3.7 in December. I take that 3.7 because it's an annual interest rate. I cut that in half, so it's like, 1.85 and 1.85. That total gives you a 3.7, but what they do is they kind of distribute it out. If you're doing it monthly, they cut that interest rate down by the number of times. So that's what's happening right here. You're taking your APR, your interest rate, whatever it is, you divide it by however many times you do it in a year, and that's how you figure out this formula, okay? So, don't get scared if you hear something is compounded, every single day. They take that APR, they divide it by 365, because that would be your M right here. And so it's a very small amount, but it happens 365 times. So it's a smaller amount, but it keeps happening. So that's all that's going on when you compound it, and we'll see examples of different spans. This last one, what it is it's what they call continuous compounding, where it's not just every second, every millisecond, it's always happening, okay? And this is where things like certain accounts will do this, but very rarely. You'll get that exponential growth like a population. You'll get a radioactive decay where these things that are in nature, they're not waiting for a clock to happen where we're going to say, okay, one day let's add a little bit more. Another day let's add a little bit more or subtract a little bit more. It's always growing, like I said, like a, some sort of a isotope that's getting bigger and bigger. Usually they get smaller, but if you get some sort of a, I'm trying to think in physical sciences, you have a mass that keeps growing upon itself based on its size, and it's always growing. That's what continuous compounding is. Now, the good news is we're not going to use every one of these every time. We're going to do some different ones, and I'm going to show you basically how to use these and what we plug in. So we're going to start with a continuous compounding, and you see here, oops, sorry, why is it all popping in? Okay, go back. Continuous compounding formula, A equals P, E, and the exponent is R times T. Now, we talked about earlier what they stand for. what's going on is the P is what your principal is, what your balance or whatever amount. Like I said, it's going to be a dollar value in an account. It could be the number of grams of a certain substance that's growing. Either way, P is what you start with. Okay, that's your initial. A is what we're figuring out. That's what you end with. So think of it as that's the start, and right there, that's the end, the finish amount. Okay? The E, remember, is always 2.7. The R, we talked about, is your interest rate, and your T is the number of years. Okay? How often this is happening. So that's what's going on here. Now, they want us to kind of refer back to this formula. This is that, excuse me, the compounding, the interest compounding formula that we just talked about a second ago. And what happens is this is how we derive the one at the top of the screen. They take the limit as m gets more, and I'm sorry, I don't know why this keeps moving forward. Okay, so what's happening is, remember this m down here is the number of times per year. Okay, so it could be 365, it could be 1,000,000. This number's getting bigger and bigger and bigger, and at the same time, this is getting bigger because that's your same m. So what they're saying is, what's this going to be as m goes to infinity? So they're going to do a little math, and the good news, you don't have to come up and derive this, but they end up getting down to all of this, and this inside part right here, if you recall from the first slide or second slide, that's what the definition of E is. And that's how they can do this. This is basically saying compounding is happening instantaneously all the time, forever and ever. Okay, now, like I said, you're not going to have to derive this on a test. You don't even have to really understand it to be quite certain, honest. You just have to know how to use this formula. Okay, when you take your quiz, you got to know that bottom formula, that A equals PE to the power of RT. Okay, and that's what A is equal to. So we'll get right to a problem, how this works. Oops, sorry. So we have $1,000 deposited into a savings account that pays 5% per annum per year. That's your APR right there. Calculate the amount in the account after 20 years. Okay? Now, they didn't say it was being compounded, but we have a couple options here. So in this case, and like I said, you normally have to define how this is going to be, but they're going to give you 3 examples of what happens. Simple interest is the first case. Okay, so remember, that formula, and go back, because I wish we could have the formulas right here, but this is what they are. You're taking the principal, which is that 1,000, you're adding the interest rate to the number 1, and you're multiplying by t the number of times you do that total. So it was 20 times. That 20 should be on the outside. Okay, little tiny mistake here. Okay, so remember the formula. I'm just going to show you guys right here to write this. I'm laughing because there are mistakes that happen in the slides, and I apologize for not catching this before we did this. But that's our formula for simple interest, okay, on the top right of the screen. Okay, so for our problem right here, the formula is right here, times t. All right, so we know the rate is going to be 0.05. Remember how I got that? You take your APR, you divide that by 100, that's going to be your R. Your principal is what you start with, and then your T is that 20 years right there. So what should happen is you plug in the 20, you get the 1 plus 0.05, and you multiply that by 20. This is how you calculate the simple interest. And I'm sorry, I made a mistake. That P is 1,000 right there. Your principal, what you start with, is $1,000. Okay, so what happens is we have 1,000 times 1.05, and what matters just as much, you have to know how to use your calculator for these problems. Okay, so I'm just going to pull that up real quick just to show you what I'm talking about. And this was the easy one, but I'm going to keep going back and forth to show you. You have 1,000 times the 1.05 equals times the 20. And that's your interest right there. That's your simple interest. It should be that 21,000. And remember, that was 1,000 right there. Okay, and make sure I'm getting that right here. Okay, no. Let's fix this. A little too much. And like I said before, remember, common sense. If I have $1,000 investment and I'm getting a 5% interest, I should not be having $21,000. So I know what the mistake is that I'm trying to fix here. Okay, so let's go back. I know what I'm going to fix right now. In the interest, this is what it's supposed to be. The example's right. The formula was just wrong. Okay, so this, let's just pretend we're starting this whole part over. This is the formula. Now, I can tell you it's correct in the book. It was just wrong in that PowerPoint slide. So that's why everything's a little haywire in this one. Go back. And you see it makes a difference. If you multiply the whole thing by 20, you're making this be a huge number. So this will make it actually work. So once again, simple interest. It's A equals capital P times parenthesis 1 plus RT. That's all in the parenthesis. So it's going to look like this. This is your times 20 right here. So in my calculator, I'm going to take the 0.05, multiply that by 20, add that to the 1, and this is what you get inside the parenthesis. All that's a 2. And now we get the 2,000, and it works out what it's supposed to be. Because what's happening is every year you're getting 5%, and that 5% is all based on what you started with. So 5% of 1,000, you get $50. Then the next year you get $50. The next year you get $50, and you do it for 20 years, and that basically comes out to be another $1,000, and that's how we get our 2,000 right here. Okay, so after that, a little bit of a screw up here, we're back to where we're supposed to be. Now the formula is right. If you download the PowerPoint, just remember that part's wrong. It should be the T in the parenthesis. So the other slide over here, this was correct. It was just that very first one, and that's what threw me off as well. I'm sorry. Okay, back to where we were on this problem here. Okay, so simple interest, we get the 2,000. Now remember, that is interest that's the same every single time. It's that $50. Compounded means you're building interest, and then every time they add interest, you have a new balance, and that new balance, the higher balance, is what they use to calculate the next interest. So in this formula, this is that, and I want to make sure you see where I'm getting each piece from. Okay, so again, I'm like I always do, I'm going to go back and forth and show you exactly what the formula is supposed to be, because they sort of fill these out without explaining that, and that's the one we're using right there. Okay, the compound, and just so you believe me, this was the compound interest one right here. Okay, this whole big thing, I'm going to write it here just so that we have it for the next piece. A equals P times 1 plus R over M to the M times T power. Okay, that's the formula for compound interest, where you make interest on top of interest. So just see where everything comes from. This $1,000 still goes right here. Your R is still the 0.05. Your M is the new one, and remember, what that's asking is, how often are you getting interest paid? How often is it compounded? And to get that answer, you look right here. Compounded annually means it's happening once a year. Compounded monthly means you get it 12 times a year, so your M would be 12. This one simply means your M is 1. Okay? So when I plug in, and then of course your T is this 20 years right here. So when I take this formula and plug everything in, I get the 1,000 and the 1 plus my R, which is 0.05, over the 1, which is my M, and the power is 1 times 20. That's how they arrived right here, just so you know where everything came from. That 0.05 is not really just because of the interest. it's the interest divided by 1 because we're doing this annually. The 20 is not because it's 20 years, it's 20 times the M. It just happens to be that the M is 1, I'm sorry, so that's why you have a 20 there. Now, of course, all of this, we have to make sure we know how to get answer. Just think of a challenge when you're doing these problems. So, looking at this one right here, okay, how they got that answer. So kind of ignore the other stuff. When you're doing this on your calculator, I'm doing a standard one right here, and most of them will do this. Start with your parentheses and move your way out. So take the 1, add the 0.05. That is what the entire parenthesis would be. Now, if you want to rewrite this whole this part again, simplified, go ahead. But now we have to take 1.05 to the 20th power. Now, most of your calculators will have this button right here. Okay, so I'm going to show you what this button is. Right here, this X to the Y. And some of your calculators may have a button that looks like this, where it's kind of a little up arrow. That just means an exponent as well. It's the exact same thing as this button right here. So what that is no matter which one you have, okay, no matter which one you have, if you want to use that button, how it works is, let's say I want to get 2 to the 3rd power. Now I hope you remember 2 times 2 times 2 is 8. I always pick something that I know the answer to before I start using my calculator. It's like a tester to make sure it works. So what you do is you hit the base 2. You hit this button, you hit the 3, you hit equals, and that ought to give you the answer. So just kind of like I said, bear with me and I'll show you what I'm talking about here. I'll hit the 2, I'll hit that power button, I'll hit the power, I hit equals, and you see the 8 appears. That's how you can calculate any base and any power using those buttons right there. Okay, and like I said, if your calculator has that little up arrow thing that I have right there in the orange box, you would do the exact same thing. You hit the base, you hit that button, you hit the power, you hit equals, and it'll give you the result. So now that we know how it works, now I want to find 1.05 to the 20th power. That is that right there. So I can do all this in one step in the calculator. Remember, we already did the 1.05. We then hit the power button, hit the 20, and that gives me this long decimal. Now, you don't even have to write it, because what happens next is you're supposed to multiply that answer by 1,000. So while it's in my calculator, I'm going to leave it all there so I don't have to round anything. And now I have this answer, and you're supposed to round it to the nearest penny. So $2,653, and that 7 means go up to 30 cents. That's how they got this answer right here. That's where that one came from. Okay? So that's how you apply this formula, this compounded interest formula. Now you'll see the next example. I'm not going to open the slide, the PowerPoint again. I'm just going to move down here and show you now what they're asking us to find is same problem where our principal is 1,000, our time is 20 years, our R is still 0.05, but the difference is, in this case, because it's compounded daily, that means we have an M of 365. Okay, yeah, some of you are going to say, what about a leap year? Usually a book will tell you, use a 365. I'm looking at the screen. I don't know why it says 360, so we're going to ignore that. It's supposed to be 365, okay? And what I care about is let's plug all this stuff into the formula. Same formula, remember? The A equals P times 1 plus the rate over the M times to the power of M times R. So when I plug everything in here, and this is what the PowerPoints won't show you, is this is the steps that matter here. We have the 1,000. We have the 1 plus the 0.05. And like I said, that should be 365. And the power is 365. And your T is 20 years. So that's what we're plugging in. Now, the good news is I can do all of this in my calculator if I know the right steps. Now, the only thing I'm going to do right now, though, is I want to do this power right here, 365 times 20, because at least I know that's not going to give me an ugly decimal that goes on forever. So that gives me the power of 720. sorry, where did I get that from? 7,300. Think of another problem. So we have A equals 1,000 times 1 plus 0.05 over 365. And the power now is actually 7,300. Now what that's saying is, if you're doing interest every day, and you're doing it for 20 years, you're going to get 7,300 different interest transactions. So instead of going one at a time, one day at a time, this formula lets you jump right to the end result. Now on a calculator, here's what I'm going to do. And I want to make sure, this is why I'm going over this, I want to make sure everyone can see this step by step here. I'm starting with the inside of the parenthesis, like the order of operations. I have the 0.05, divide that by 365, and I'll tell you this is going to come out to be an ugly long decimal. No problem. That's the fraction here. I add 1 to it, and now what's on my calculator screen is this entire parenthesis. So the problem now, without me writing it, is A equals 1,000 parenthesis, this number, 1.000136986, blah, 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 end of parenthesis to the power of 7,300. Now the important part is what you do next, and you have to recall that when I'm doing something in the order of operations of algebra, I have to do exponents before I do the multiplication. So this number that's in my calculator, I don't multiply it by 1,000, I have to do the power of 7,300 next, and I can do that while it's in my screen. No rounding, I didn't even have to write this on the top. I'm going to take that long number and take it to the power of 7,300. So I hit that exponent button, hit the 7,300, hit equals. Now this right here is everything. Okay, this is everything to the right, the parenthesis to the power. And lastly, I just multiply that by 1,000, because that's what's in front here, my principal. And you see I get $2,718.09. So they got the right answer. Just so you guys know, this should have been a 5 for the 365, and that should have been a 5. Like I said, I think that was just a little typo, but they calculated it correctly. Okay? So now we have the compounded continuously, and remember the rule for that. When it says it's compounded continuously, that's that A equals P to the PE to the RT power. Now the good news is my R is still the 0.05. The P is still the 1,000. There's no M to worry about because when you're doing it continuously, it's like M is infinity. So you don't worry about an M because you use this formula which doesn't have an M. We have to get the time, which we already knew was 20 years. So I plug everything into here. We got 1,000. I don't need to write it. It's all right here. So there's your formula. And just like before, we're going to use our calculator, and I'll show you the other trick on this one so that we know how to do this when this comes up. We have 1,000 e to this right here. Now what's nice is your calculator has this button right here. It's e to the x. So whatever's in the screen of your calculator, if you hit the button, it takes e to that power. So for example, when I type a 1 and hit the e button, it's going to find me e to the first. And as we already saw, remember that's at 2.78, 71828, all that. So if I want to find e square, I put a 2 in here, I put e square. If I want to find e to the 10th, I put a 10, I hit the e button. You see how it's not that bad. You're typing in the power of e. Well, that's what I'm going to start with. I don't know the power of e, but I know it is this. It's 0.05 times 20. That's my rate times my time, and I get this. Okay? I then take that, that's the power of e, so we get this, and then we multiply that number by this front principal, this 1,000, and you see we get this, which is the same answer we have right here. Okay? So that's how we're going to apply all three of these. So this, not this page, but the slide before. Let me go back and show you. This is your key to this entire section, 3.1. This is one that, you know, if you want to, take a screenshot of it right now, or look at that PowerPoint, or look in your ebook and keep this filed away. And what's great about this slide is it's got the definition of everything. It tells you what they are. So you can fill all those in. All right, so now we're going to look at another one. $1,000 invested in a 6% interest account. Oh, by the way, back here, what this is doing, this is showing you how it works, the different styles. Simple interest is the one that's going to give you the least amount of money because your interest doesn't build on itself. You know, every one of these is $1,000, 20 years, 5% APR, but the simple interest only got you $2,000 at the end. If you're doing yearly interest, compounded yearly interest, it builds on itself. It's once a year, but it does get more. You get to $2,600. If you compound your interest daily, it builds on itself a little faster, even though the numbers are smaller, you know, as you're doing it each day. But the end result, you're up here to $2,700. And if you're doing it every single possible nanosecond for the 20 years, it still caps out. It's at $2,718. So it's not much more than this one. We're talking 19 cents more, compounded daily versus compounded continuously. It's not like it's a ton, but this is just showing you how it works, the progression you get. All right, now we get back to our problem. $1,000 and a 6% interest, compounded continuously. So the moment you see compounded continuously, you have to think of that PERT problem, that formula right there. Okay, out of the three I showed you a minute ago. That is the one that's always for continuously. Continuous amounts, anything like that. So our principal is 1,000, that goes in place of the P. The R is the 6%, so we go with the 0.06. The T is 5, and we just need to go figure out what this is on our calculator again. That's what a lot of this section is about. So remember my style here. I'm going to calculate the power first, 0.06 times 5. So that right there is the power of E. So I hit this EVX button. I then multiply it by the front number, the 1,000. Now, it's always 1,000 in these examples, but your principal can be anything. This is whatever your principal is, this 1,000. And we get $1,349 and round that to 86 cents. That's what they have. Notice you don't round anything until the very, very end. And this is important when you deal with these long decimals and these powers that are big numbers. If you start shaving off some of these decimals or rounding up or down, it will taint your answer because there are more steps to go. So this is why I'm trying to show you how to leave this all in your calculator so you can see what's going on. Okay, so in this case, remember, the A will tell you the balance at the end of the time, in this case, the 5 years. If they ask you, well, how much interest did you earn? Well, remember, $1,000, which was what you first deposited, subtract that out, and this $349, that's how much interest you earn. So you got to be careful of the question. Sometimes they're going to say, how much is the account worth after 5 years? Your answer is $1,349. If they ask you how much interest was earned, you have to take out the principal once you get this answer. And notice the amount I gained was the $349. So you're going to see both varieties of those questions. The important thing is, obviously know how to use the formulas and get the answer, but you have to make sure you answer the question that was being asked in each of these cases. Okay, so we have another one here, 5-year certificate of deposit that earns 5.75 compounded continuously, $1,000 invested in a CD, graph the amount as a function. Excuse me. So what happens is, this is just one where you can use the formula and play with it. It's just trying to get you to see what your balance is based on the different 5 years, what's going on. Okay, it looks like it's a straight line, but it's not. Okay, this PERT is got a little curve to it, a little curving up. You just can't tell because of how the zoomed in picture is, but it does curve upward here. All right, computing time, a growth time in this one. So we have an investment of $5,000 growing to $8,000, 6% compounded continuously. So what the question is how long it'll take. And this is what's going to happen in these problems. They're going to ask you different questions. Not always are they going to say, what's your final balance or what's your interest? They may say, how long does it take? Or what's the interest rate? So you have to know the question. Notice the $5,000 is your initial investment. That's your principal right here. So again, what I wish they would do every time is to write the formula out so you can see it. So this is your $5,000, like we've been doing, okay? Now what's the new one is, they tell you it's going to grow to 8,000. Remember, the A is your ending amount, your 8,000 in this case. You're not finding A, they're telling you what it is. So what you also know is you know the interest rate is the 0.06. And what you don't know is the T. That's the mystery amount. That's the part that we have to try to figure out. Okay, so let me, they've already worked this out, but let me kind of work it out step by step so you can see. You've already gotten a preview of it, but just kind of show you how it would work here. So you use that formula, and the reason I know it's that formula is because of the fact that they said compounded interest right there. That always means use that formula, or compounded continuously. Sorry. Continuously is the key word, not compounded. They all say compounded. It's the continuously that I'm looking for, that C word. Okay, so it's A equals PERT. They want you to solve for T, and remember, because they ask you how long, they don't know what T is. That's the mystery. That's the variable we need to solve for. So now we plug them in just like I had a second ago, and T is the one we're missing. So you have to solve the equation for T. You have to use your algebra. Now what you may not realize is the first step, we need to divide by both sides by the 5,000. Now again, I don't like how they did this, but if you divide both sides by 5,000, what you're doing is we're trying to get T by itself. This is the first way. I want to get rid of that garbage in front. So I get 8,000 over 5,000. That becomes like a 1.6, and we're left with all of this. Okay? So just so you know how they get this next step, that's what they did. And then they reversed it around. It doesn't matter if you move the E to the left or you left it on the right like I had. It's going to do the same effect. Now is your, pretty much the only trick you have to know in algebra today is when you have a variable up in the power, you can't do anything with it, but you can if you take the natural log of both sides. So, we've talked a little bit of natural log. You've had that before. Natural log. There's a button on your calculator that's ln, and what's important about ln is when you take natural log of an e, it cancels it right off. And then what you're left with is just what the old power was, in this case the 0.06t. And then to solve for t, we divide both sides by the 0.06. And like always, I want to make sure we can do this in our calculator here. All right? So we see the answer on the screen, but make sure you know how to do this. So to find a natural log, most calculators, now some of your calculators you're going to hit the ln button and then the 1.6 and you hit equals. Majority of them you do them sort of backwards. You type in the 1.6. Then you hit the natural log. So that's what's on my screen. I don't even have to hit equals. What's on my screen is in fact the natural log of 1.6. I then take that answer and divide it by 0.06. And you see how we can get to this answer right there without having to write things down. I know it sounds like we're trying to cut steps out, but we're actually not. We're trying to leave it all in our calculator so that we get the most precise answer possible. At the very end, that's when you can round it, and they say round to the nearest, second, the hundredths place. And what this is saying, going back to your problem, if you had $5,000 with a 6% interest, to get to 8,000, it'll take almost 8 years, a little less than 8 years. So that's what we're trying to figure out is how long is it going to be, how long will it take? And you see these examples a lot, maybe not with the compound interest, but other problems where it's something like, well, my kid's going to go to college when he's 18. I want to save this much money. How long will it take to reach that money here? If I put in this much, how long will it take to reach that 100,000, whatever the case, knowing the interest, knowing the rules, you can actually look at it. And if they say, okay, it's going to take 10 years, well, okay, when he's 10 years old, I'm going to start putting the money in. If it says it's going to take 35 years, then we have to change some things around. We have to either invest more or all that, to get to that goal. And that's what all this is for, is to help us figure out how, what do we need to do? What's our end result? How do we get there? Okay, so our last couple examples, how long will it take an investment to double if it's invested at 5%, 5.75% compounded continuously? So once again, the continuously means we're using the A equals PE to the RT, that formula. So here's a unique part. When they tell you the investment will double, Notice they didn't tell us how much we started with and how much we had to end with. All they said it's going to double. Sorry. So what that means is if my initial investment is P, the principal, whatever it is, the end result, the A, is going to be 2P. It's just going to be twice it. So if it was $100, A is 200. If it was 10 million, A is going to be 20 million. And we don't even need to know what that is. We just have to use A equals 2P. So this right here on the right, this is what we're looking at. 2P equals, and again, they're going to miss a step here, so I'm going to write this over to the side. Okay, so this is my initial formula first. Okay, we know this, and remember, we don't put in that amount right there. We put in the point for R, 0.575. That's what goes in there. Remember, divide it by 100. Now, in place of A, I'm putting that 2P. And then what's unique is it doesn't matter what your principal is because you're doubling it, so it's irrelevant. What I'm going to do is, like we did on the last problem, I'm going to divide the P away, and all I get is this right here. And then just like the last problem, I'm going to take the natural log of both sides. So you see this will kind of catch up to where they are in this problem. I just wanted you to see how they got to this because it's kind of a mystery sometimes. So it's the same thing. They have it on different sides. It doesn't matter. But I'm trying to solve for t. And when it's up in a power and I have an e here, the rule is take a natural log of both sides. That'll make this cancel. And I'll be left with 0.0575 t equals natural log 2. Divide by that number in front of t, and I get this. And when I plug this into my calculator, remember, take the natural log of 2, which is, and I can't show you enough on the calculator because this is what trips a lot of people up. So I'm going to plug in natural log of 2 first. So you hit 2, then you hit natural log. Then I divide it by the 0.0575, and I get this, and this is the t, little more than 12 years. That's how long it'll take to double my money at that particular interest rate. Now, as you can guess, if this is higher than 5.75, it's not going to take 12 years. It'll take less time. If that's a lower interest rate, like in real life, it's going to take you 20, 30 years, just depending on what that rate is. Okay, so the last slide here is kind of a little summary of a couple of things. There's some formulas on what you can do, but I'm going to tell you, I wouldn't memorize these right now because sometimes they can be a little more complicated than they are helpful to people. So what I would suggest is don't do this yet. What I want you to do is go back. I want us to do these 3 formulas right here. I'm going to save this. Not move the screen all the way out of it. Let's just use these so when we do our homework, that's what I'm going to refer to. That's the stuff that I want you guys to be looking at. Okay, so back to your course here. We're in 176. Hopefully you guys are having no problem getting through this because you made it this far. Assignments, we did 2.7 the other day in homework number 6. So we only have a few more problems in this homework section. And I'll do these 5 today here, these next few, just to make sure we're all on the same page. Okay, so number 19. Use a calculator and evaluate a to the nearest cent. So let's make this a little bigger. Okay, hopefully that's a little more visible for everybody. If you guys ever are having trouble seeing some of these screens, feel free to email me and I'll make it a point on future lectures to crank up the size a little bit more. Okay, so in this particular formula right here, I always like to rewrite it anyways, a little larger, just so I know what in the world I'm doing here. E to the 0.08t, and what they want us to find is, use a calculator, evaluate a to the nearest cent, and they give you 3 different t values. So let's say, starting with the first one, t equals 3. So, to be sure what we're doing here, e to the 0.08 times 3. I'll use a parenthesis there. How do we get that? What do we do? Well, this is, again, a calculator problem. All of this can be done in one step, and like I said earlier, I'm not trying to get lazy on you guys for doing this. I want you to try to do it all in one so that you don't have to rewrite You don't have to round because you can't write endless decimals. So you're going to have to round at some point, and then when you start plugging in rounded decimals to your calculator, your answer becomes off. So procedure-wise, how to do this? I'm going to take the power first, the 0.08, multiply that by the 3. This now is the power of E. So while it's on the screen, I just hit the E button, and then I multiply by 8,000, and I get this. This 10,169, and they don't want you to round to the final answer, and then you round to the nearest 10. Okay, and there's our first one. So we're doing the same thing when t equals 6. So the only difference here is this now becomes a 6. But what I like about this problem, this one with the 3 parts, it makes us use our calculators. Okay, so again, I'm taking the 0.08 for the interest. Now I'm multiplying it by 6. Hit the E button because that's the power of E. Multiply that result by 8,000. And this will be the answer for the second part. 12928.59 rounds up, so it should be 0.6. And the only thing that's going to go wrong here is if you don't know how to enter this in a calculator, you're going to get the answer wrong, or you make a little, an error when you're typing it in. So the last one is you plug in 7. I don't even need to write it. I'm going to take 7 times 0.08. That's the power of E. Multiply that by 8,000. And we get this. So I want you just to, these first problems are great literally because they get you comfortable with the device that you're using. Get comfortable with your calculator. That's what literally matters the most when you're doing these is you have to know your calculator because this is what you should be using when you do the homework, when you do the quizzes that count, and when you take the final exam. I don't want you using some different calculator or not knowing how to do it. This will get you to know. Okay, now they want us to solve for R to 2 decimal places. So remember how this works. When they tell you to solve for R, but R is up in a power, we have to figure out what to do on that one. So 3 equals E to the 7R. The only way to get rid of that is I take a natural log of both sides. And that causes the E to cancel off, and I'm left with basically whatever the power was. Divide both sides by 7, and that's your R. And if you're wondering, in some classes, you take another calc class, they may say leave it right here at natural log of 3 over 7. That's the precise answer. Here, when it says go to 2 decimal places, that's your permission, your go ahead to use your calculator. So how do I plug in natural log of 3 over 7? Hit the 3, hit the natural log, so this is the natural log of 3. Divide that by 7, and we get this. And this is what R is equal to. See, go to 2 decimal places, so it should be 0.16. And that's it for this one. That's all we need to do. Okay, so hopefully that's clear for everyone. Let's start looking at number 27. Okay, number 27. A little more calculator work, but I'm going to find some dollar values this time. So we have an investor bought a stock for $40,000. 15 years later, the stock was sold for $60,000. Compounded continuously, right there. I'm not even going to do any more except for know that A equals PE to the RT. I know that immediately when I see that word continuously. Okay? And then they ask you, what's the annual nominal rate of interest did the original $40,000 investment earn? So we have to remember, A is the ending amount, the $60,000. Principal is the $40,000, what you started with. We don't have an interest rate, but we know that it took 15 years. All right? So this is the same kind of problem as a couple minutes ago. We need to solve for that R right there. That's our mystery. That's the thing we find, and sure enough, they're asking us, what's the rate of interest? So how do I solve this? Remember the first thing, get rid of this number in front of the E. Divide both sides by 40,000. Now, if you need your calculator to do it, not a crime. I have 60,000 divided by 40,000, and I get this 1.5. Now, just so you're clear, what that is that's how much the multiplier of your account. You know, your original money was times 1.5. That's how much it went up to get to where we are. Okay, so now we have the 40,000's gone on the right side. We have just the 1.5 on the left. We have the e to the 15r. Now, whether you call it 15r or r times 15, it's the same thing. What we have to do next, remember, is take the natural log of both sides. That makes this cancel off, and we have natural log of 1.5 equals 15r. And it's almost identical to the last problem. We have to go and take the natural log, divide by the 15. And again, every problem pretty much is going to use this calculator. Natural log of 1.5, right there. Divide that by 15, and we get this number, and I believe they say, let's see, so it's 0.0273031, and it goes on forever. This is where you have to make sure you answer this. Now, what's interesting, if you notice, that's the R. They're asking the interest rate right there. So we've done this before where we have an interest rate like 3.6. You divide it by 100 to get the 0.036. Here it's the opposite. This number right here, what's in my calculator, now to get the interest rate, I multiply that by 100, and there's my interest rate, this 2.703. All right, so that's what I'm actually going to type in here is 2.7. They say round to the nearest two decimal places, but remember, where's my calculator? It's a 0, 2.70. So I could put the 0 there, I don't need to. And there's our answer. Okay, so let me go back here. So if you need to pause the video and look this over, feel free to. If not, I'm going to go on to the next one. Okay, so same question. They're asking at what rate will a compound continuously? And say again right here. As soon as I see this, remember that tells me A equals P E R T. And I like this formula a lot for the fact of you have less variables. The other ones have the M. So you have an extra piece. You know, is it monthly? Is it daily? Is it yearly? This cuts that out. So you just have these four variables, the A, the P, the R, and the T. And normally, they're going to have to tell you something. We just have to figure out what the pieces are. There's one missing. So there I know my T is going to be 8. The rate is what they're asking, so that's going to be my mystery. Now, they don't tell us the A or the P, but remember what they tell us? Your investment's going to triple. So that means this A is going to be 3 times P in the end. So that's how I can get away with it. Now, I still have a couple of variables, but remember what happens here. It tripled, so that's 3P, but these P's cancel, and now I have 3 equals E to the 8R. And I just have to solve this. And you're going to learn after a quick few of these, it's the same exact problem after a while. And you're going to start skipping steps because you already see what's happening here. That cancels. You have the 8R. Divide both sides by 8. And now, get that calculator out. And we get natural log of 3. So hit the 3, hit the natural log, divide it by 8. We get a decimal that looks like this. Recall again, they want an interest rate percent. Okay, so this is not in the percent form. The easy fix is multiply that by 100. Now you have your APR, and it's this 13.73. And again, notice I almost got tricked here. Do not round until your final answer. So notice we haven't rounded at all until now. This time they want us to go to the nearest tenth, and I know that's frustrating for a lot of you because you get the right answer. If I typed in 13.73, I'm going to guess I'm going to get it wrong. Oh, they gave it to me. Okay, they did want it to the nearest tenth, so you could have gotten away with 13.7 is really what they wanted. I went further, and this is how I would be on a real test if this was in person and on paper. If you went more decimal places, I'm never going to mark you wrong. It's when you round too much or round it incorrectly. But officially, they wanted the nearest tenth, so just make sure you make a point to read all that so you're not, messing that up. Okay, and one more, or is that it? Yeah, number 35. So we have a couple. Mathematical model for world population growth over short intervals is given by this. Now notice this looks just like the A equals PERT formula. And what they're saying is when the time is 0, when it starts off as nothing, P0, P naught, P sub 0 is the initial. Let me use a better word. Let me just say that's the starting population. Okay? Then the P is going to tell you what the population is as time goes on. So this will tell you whatever T you plug in there, you're going to get that. So we have to figure out how long it will take the world population to quadruple if it continues to grow at its current continuous rate of 1.36%. So remember, that means 0.0136. So if I get that formula, their formula, which is similar to what we've been doing, first off, remember, this is what we started with. They want to know how long it takes to quadruple, so what's going to happen is my end result, we don't know what the starting population is, but what we know is it's going to be 4 times that one, so it's 4 of these. And then they tell us the rate is 0.0136. The question is, what's the time? So remember, I can divide both sides by this P naught. It's like when I was dividing both sides by regular P. It's moot. It doesn't matter. What matters is we have 4 equals e to this. And notice, same thing every time. Natural log of both sides. ln and the e cancel off. We have natural log 4 equals all this. And I divide both sides by that number that's in front of my t, this 0.0136. Okay, so we're right back to the calculator. So you notice the last 3 or 4 problems, they're all the same in terms of steps on our calculator. We're taking natural log of 4, divide that by 0.0136, and we get this. The question, remember, was how many years will it take it to quadruple? That's the t. Well, it's going to take almost 102 years. And, oh, I'm sorry, they're actually making us do a little bit less here. They want us to fill this part in first. So remember, there's a 4 that goes in front of here, and the r, 0.0136. That's the first part. So they're kind of walking you through it. We got that. Now is the answer that I'm looking for. 101 point, let's see here, round to the nearest 1 decimal place. Hope that's good, and there we are. Okay, so I think that's all that we've got here. I don't think there's a number 39. I can't remember though. Yeah, that was your last one here. So that's it for the homework. Like I said, this is a shorter week because of the holiday, and also just because it just happens that these 2 sections are a little bit less invasive, less going on here. So that's it. You should be able to finish all of this homework for week number 6, and remember, start homework number 7 next week. We're going to do sections 3.2 and 3.3. So if you get a jump, if you get done quick, feel free to start exploring this. I'll try to, like always, get a video out at the weekend or the end of the weekend, beginning of the week, and another one midweek like this one. So we're going to keep just chugging along doing these things. So if you have any questions, shoot me an email and I'll clear that up for you, and we'll just keep moving on. All right, have a good one.